Deep beneath the waves, hidden among coral reefs, lurks a tiny predator with a punch so powerful. It shatters shells, cracks glass, and even boils water. This is the mantis shrimp, nature's ultimate biomechanical brawler. But what makes its strike so incredibly powerful? And what can human engineers learn from this marvel of evolution? Let's dive in. At first glance, the mantis shrimp looks like a harmless little crustacean, but don't be fooled. This creature packs one of the fastest and most devastating punches in the animal kingdom. The secret? A spring-loaded mechanism that functions like a biological crossbow. Inside the mantis shrimp's club-like appendage is a highly specialized structure called the saddle-shaped spring. This stores potential energy as the shrimp contracts its flexor muscles. And when it's ready to strike, a latch mechanism releases all that stored energy in an instant. The result? A hammer-like blow that accelerates at 10,000 G, faster than a bullet fired from a gun. How fast are we talking? Well, this punch moves at an insane 23 meters per second, faster than the blink of an eye. In fact, the strike is so rapid that it generates cavitation bubbles, tiny vapor pockets that implode with tremendous force. This secondary shockwave delivers an additional impact, meaning even if the shrimp misses its target, the resulting shockwave can still stun or kill its prey. This phenomenon, called supercavitation, is the same principle used in high-speed torpedoes and experimental naval technology. The force is so intense that it momentarily generates temperatures close to the surface of the sun. So how does the mantis shrimp's club withstand such repeated high-impact blows without shattering? Nature's solution is a material tougher than any synthetic composite we've ever created. The club is made of a unique structure of interlocking chitin fibers arranged in a helicoidal or spiral pattern. This design disperses stress across multiple layers, preventing cracks from spreading. Engineers are now studying this design for impact-resistant materials in everything from military armor to aerospace engineering. Biomimicry, learning from nature's designs, is revolutionizing modern engineering. The mantis shrimp's punch has inspired new research into ultra-tough ceramics, advanced robotics, and even next-gen prosthetics. Scientists are working on developing synthetic materials that mimic its layered structure to create lightweight yet nearly indestructible protective gear. But the inspiration doesn't stop there. The shrimp's rapid energy release mechanism could also lead to more efficient robotic arms and exoskeletons, enhancing human performance in industries like construction, space exploration, and even medicine. If its punch wasn't impressive enough, the mantis shrimp also has some of the most advanced vision on the planet. Unlike humans, who see 3 primary colors, red, green, and blue, the mantis shrimp perceives 12, spanning ultraviolet to infrared. This supervision enables them to detect hidden prey, polarized light, and even cancer cells under certain conditions. Scientists are developing new imaging technologies inspired by their eyes, potentially revolutionizing medical diagnostics and optical devices. From high-impact materials to revolutionary optics, the mantis shrimp is more than just an underwater warrior. It's a blueprint for the future of science and technology. By studying this tiny yet mighty creature, engineers and researchers are unlocking solutions to some of humanity's biggest challenges. So next time you see a mantis shrimp, remember, this little crustacean is more than just a sea creature. It's a living, punching, high-speed engineering marvel. And who knows, the technology of tomorrow might just be hiding in the ocean depths today. Thanks for watching. If you enjoyed this deep dive into nature's engineering, don't forget to like, share, and subscribe for more incredible science content. See you in the next adventure.